Hello, grade 2 teachers. Let's talk about some ways that you can connect computer science into your living systems unit. So, your computer science curriculum has a lot of knowledge in it. There are two understandings and a number of skills and procedures, but the knowledge area is really, really heavy. So, they've given you a lot of information and ways to cover those understandings and meet that learning outcome that students follow instructions and relate them to outcomes. So, that's pretty simple, basic. Kids are following instructions in school all of the time. The kindergarten and grade 1 and 2 curriculums talk a lot about following instructions as well as also a little bit about creating instructions. So we can find ways to connect that not only into our computer science teaching that we're doing, but also just into the general activities and things that we're doing in our classes. So throughout this video, I'm going to show you some ways to connect some of the more general ideas of computational thinking, design, creativity into this living systems unit. And we will also see how we can connect at least one of these specific skills and procedures into this living systems unit as well. But again, make lots of connections to design and computational thinking. And there's just more of those knowledge outcomes. Looking at creativity, we want to encourage students to find different ways to solve problems or to reach the same outcome. Thinking of something in a new way or finding a new way to use something are all ways to encourage creativity and have students see applying it in different areas and understand how to be creative, and also to understand the advantages that creativity can have in helping us solve problems or reach particular outcomes. As with all of the computer science curriculum, design thinking is a thread that runs through. We'll look at some ways that you can incorporate some design thinking into your living systems unit. And of course, we'll also talk about computational thinking and how that can be ingrained into your living systems lessons as well. We're asking students to compare things, like in this procedure where we're identifying similarities between offspring and their parents, asking students to look at specific attributes of something is getting into the decomposition piece of computational thinking and looking at ways that they are the same, and is going to be dabbling into that pattern recognition, and looking at ways that they're different can be recognizing patterns as well. That the adult of a certain animal has certain attributes that make it an adult, and the child has certain attributes that make it a child. And there may be those other stages that we look at also. Anything that you're doing in class as a lesson can incorporate the computer science skill of working in groups or on your own to create instructions. So you need to bridge the gaps. So a lot of this specific instruction creating and following and thinking about instructions and how we have to break things down into steps to make them make sense, this stuff hasn't maybe been explicitly taught to your students. So you're going to need to do a little bit more with that. So if you have the opportunity to incorporate coding language into your daily routines and activities, you can tell your kids that teaching a computer or a machine to do something is just like how I teach you to do things. Really, you guys are like my little robots, and I've taught you a whole bunch of algorithms already this year. You know what to do when the recess bell goes. You know what to do when you come in the morning, and those are algorithms that you, my little kid bots, have learned. So if you use that language in your classroom, anytime that you're working through instructions with them, asking them to create instructions or follow instructions or repeat instructions that they know, you're making that connection into that computer sciences piece as well. So an activity might explicitly be able to be connected to the computer sciences, but there's also always that overarching way to connect into everything as an extra layer just by bringing up that computer science word, like maybe algorithm, or asking kids to repeat back the instructions, and you're just working in those instructions. So if we look at a simple activity where maybe this is starting out with a classroom discussion, and we're going to talk about how are the adult chicken and the baby chickens the same. Well, they have 2 feet, they have a beak, they have 2 eyes. How are they different? Then we'll have these conversations. Well, what makes the adult chicken an adult, and what makes a baby chicken a baby? And could you tell me how you could explain to someone else how to tell the difference? And so now we're taking some things about learning about living systems, learning that thing about differences between adults and kids, but we're also connecting in the computational thinking and considering attributes. And we might talk about something that the students would know, which is the life cycle, or how children or baby humans are different from their adult counterparts. And we could talk from going from the chicken into the human and discuss, well, do chickens have this many stages? Do you think there's 6 at least specific different looks for a chicken? And maybe we would just chat that through and come down to, well, not as many. Well, their life cycle isn't as long. And then we can have conversations from something that we're connected to. Now we can start to apply this into other things. So if we move into representing life cycles of various plants and animals and discussing and comparing those life cycles of various plants and animals too, we're going to continue on and with what we've already been doing, decomposing, looking at the different attributes, what makes it specific, does it lay eggs, then it probably follows this pattern. Asking those questions, making those connections, that's going to get into the pattern abstraction, and then starting to think, well, what else? What other animals lay eggs and might have a life cycle like a chicken? How can we apply that? And then maybe we can move beyond to the algorithm design, and are there some rules around this? Like, what do you think we could come up with? Like, what always happens? Well, they always get bigger. Doesn't matter what species it is. The young version is always smaller than the adult version. So now we've framed up an algorithm and a bit of a rule, and we're also still talking about these skills and procedures in living systems. If we're asking students to do a life cycle, this is a really simple connection to the algorithm piece, putting things in order. So obviously ordering animal life cycles in the different stages in order is practicing that skill as well. And if we ask students, as I had mentioned earlier, what other animals have a life cycle similar to a chicken, we're doing that pattern abstraction piece where we're taking out what's important, not what it looks like, not what kind of animal it is. Right now, we're actually focusing on its life stages. Does it more or less have an egg, baby, and adult life cycle? What other animals have these types of cycle? Now we're abstracting. We could come up with those instructions for how to put a life cycle in order, and then we would also be covering this computer science outcome about creating instructions again. If you would like to give your students a little fun on the Chromebooks or computers practicing life cycles, I have a game created in Scratch. This link will lead to the playable version of the game, which was a great way just to practice or show that you know this particular life cycle. If you have the interest or you do Scratch with your grade 2s already, I know that grade 2 might be a little bit low for learning and working in Scratch programming, but I do know myself of some grade 2 teachers who have delved in with their classes. So there's also the student version of this. So this would be a big extension. This would be doing your life cycles piece, as well as including a whole bunch of those computer science skills and procedures as well. So all of these here, I'm not going to read them out, but this is obviously we're using Scratch. This is full on programming, coding in Scratch. The first link up top leads to a set of Scratch cards. So on the cards are the big blocks. They show the students exactly what needs to be put in to create the code in the Scratch template. You can follow that link or use that scan code there, and it will take you to the actual project that you can remix yourself. You could do this. You could do this as a class, put it up on your projector, go through the remix project and work through it with your students together, sharing ideas. If you're inclined to have your students using Scratch themselves, you can have them go to this link, click remix, and then they can see that all of the sprites are already in there. So the frogs and the eggs and all of that stuff is there. The instructions for the blocks that you need to program are on the cards. So it's pretty straightforward and easy to follow if you're familiar with a little bit of block programming already. So I would encourage you to give that extension a try if you have some kids that are interested in learning to program or have been doing that. It's really fun, pretty simple and straightforward. You really just do have to copy those blocks that are there. So those are some ways that you can connect computer science into your living systems unit. Have fun learning new things with your students with the coding. It's something that we aren't used to, but we know is really, really important for them to learn.